Okay. Then message filtering. Message filtering. As I told you before, every message transmitted in the CAN bus is known to every other node in the bus. So every node knows about that. There is some bus activity. But when they need certain packets, they will use a filter. They used to call it as a mask filter. That filter will be applied on the identifier of the packet. If the identifier, if it through the mask, they will take it and they will process. If it is rejected by the mask, they will simply ignore it. In that way it works. Every node used to have a message filter. They will pick the message that they want and work on that. That's why we have a message filtering. Then bitstream encoding. When you transmit series of bits one after another, it is in the digital electronics, they used to do something called as bit stuffing. So you cannot have 6 consecutive dominant or 6 consecutive recessive in case of CAN. When you have 6 consecutive dominant, there is a possibility of understanding that as active error. If you have 6 consecutive recessive bits, there is a possibility of interpreting that as a passive error. How to avoid that? For that, what they are doing, if they have, though you have 6 consecutive zeros in your data bits, after 5 consecutive zeros, they will introduce a complementary one. This complementary one is introduced in order to avoid the confusions. This is data bits. That's why we stuffed it. Don't misunderstand that as an error. That's why they brought this bit stuffing concept. In a CAN packet, you never find from the start of frame to the last bit of your data field. You won't have any consecutive 6-0 or 6-1. You cannot find it. Why? They use this process of bit stuffing. After 5 consecutive zeros, they will introduce a complementary one. After 5 consecutive ones, they will introduce a complementary 0. This is called as bit stuffing in the CAN. Let me show you one diagram, which is in that, yes, this diagram. See here, this is my original CAN frame bits. This is start of frame, and then here I have end of frames and other stuff. This is 3 bits for interframe space. Okay, now this is my arbitration field. In that, ID is 11 bits. So when you see the ID, it is 1, 4, actually 14 in X. I told you before, the transmission of bits from the transmitter will start from the MSB of the identifier. After start of frame, they will start transmitting the MSB, that is lost bit. From here, it used to go out one after another. When you see that 1, 2, 3, 4, 5, 6, we have 6 consecutive zeros, including start of frame I am talking about, because the start of frame also taken into account. From the start of frame up to CRC field, whatever the things that you have, all of them will be bit stuff. If as we have 6 consecutive zeros, they used to introduce a complementary one after 5 consecutive zero. Okay, you can ask me now, as we introduce a complementary one, now the identifier is changed. Now the value of identifier is 94. Do you agree? See, 0, 0, 1, 0. This is 4. And then 1, 0, 1. It is 9. Actually, my expectation is transmitting 14, 1, 4. But I am transmitting 94. How does the receiver will take that? Base identifier itself we changed, right? From 14, we changed that to 94. That itself a great mistake. Is that true or not? But actually, how the receiver is able to decode the 14 from this? It's very simple. The receiver will keep on monitor from the start of frame. They will simply count the bits, the nature of the bits. It is first 0, and then second consecutive 0, third consecutive 0, fourth consecutive 0, fifth consecutive. Because they are going bit by bit only. From the transmitter, they are going bit by bit. So the receiver is able to get 5 consecutive zeros. After that, receiver will automatically know that these are the bits, because the start of frame to last bit of data frame will be bit stuffed in the can. So it will simply ignore the one at the 6th position and will jump to the next incoming bits. So it won't consider that one. So it is simply removing it. When they ignore that, again, the receiver will get all these data, and then when it combines, he will get again 14 only. So we are not losing any, whatever that we transmitter is received perfectly at the receiver end. Only thing is the receiver knows that when we have 5 consecutive 0, the next bit is a bit stuffed bit. Similar way, when you have 5 consecutive 1, next bit will be, if they find a 0, they will see that, okay, this is a stuffed bit, we have to ignore that. They will ignore it. They won't digitize that. They will look for the next incoming bit. That is how the bit stuffing works. But the thing is, the bit stuffing will be done from the start of frame till the last bit of, I think even the CRC field also they are having. Last bit of CRC. Till that time, they will do this bit stuffing. All these bits will be bit stuffed. See here.
I have one doubt.
Please.
Here in bit, not in that data frame only.
Yeah.
Yeah. Here we are seeing 5 consecutive 0 bits now.
Yeah.
If we have actually, if we have one, there will be no bit stuffing in it, right?
No, automatically if there is a 1 after 5 consecutive in the data frame itself, if you have 1, we no need to have bit stuffing for that. Yes. Okay. Only thing is, see, from the start of frame, you see the top one is the original, right? Okay. First 0, second 0, third 0, fourth 0, fifth 0, 6 0. 6 0 we have consecutive zeros we have here. Though it is not, we should not do like that. We should not transmit 6 consecutive zeros. Okay. That's why after 5 consecutive zeros, we introduce a complementary one.
When what will happen if we transfer consecutively 1.
Okay, instead of 0, if we have consecutive 1, what will happen? Is that your question?
Yes, yes.
Okay, after 5 consecutive ones, they will introduce a 0. In this case, they introduce only 1. That is because all we have is consecutive zeros only in this example. If you have an example in that you have that is 6 consecutive ones, what they will do means after 5 consecutive 1, they will introduce a complementary 0. The inverse of that will be introduced.
Okay.
This concept is not new to CAN. It is there in digital electronics for a long period of time. So when they do it via communication, they used to do this bit stuffing. The same thing is followed in CAN also.
I have one doubt.
Yes.
So here, what we are saying means in the original data, they are consecutive same polarity bits, right?
Yeah.
So what if first 5 bits is 0 and sixth bit is 1 and remaining bits are 5 zeros and sixth another bit is 1. So it would be the if the original data is 5 zeros and 1 means what will happen in that case?
There is no need of bit stuffing at all. It will be transmitted as such.
Okay.
They won't introduce any additional bits. The bit stuffing will not happen for that particular frame.
So bit stuffing will not be happen or not applicable for that particular frame, right?
Yes, for that particular frame, the bit stuffing will not be done. Only when your the frame to be transmitted has that is 6 consecutive zeros or 6 consecutive frame, then the game starts. The game of introducing bit stuffing will be done. Otherwise, there is no need of bit stuffing at all. If the real mails packet itself like 5 consecutive zeros and then there is a 1 and then otherwise the 5 consecutive ones and then if there is no requirement to add, otherwise there is no requirement to bit stuff, they won't do that by force. So it is there should be a need for it. Only then the bit stuff.
So from which side? I think from transmitter side, this bit stuffing will be happening, right? Or receiver side?
Transmitter only will do the bit stuffing and receiver will simply remove the bit stuffing. That's all.
Okay, thank you.
But in CAN, there is no a variety of people, like group of people are called as a transmitter and another group of people called as a receiver. Everybody can transmit and everybody can receive also. In CAN, they can transmit as well as they can receive. It is a multi-master, the CAN thing. That's why like every issue will do that. Every issue will do that when they are transmitting. Every issue will remove the bit stuffing when they are receiving. Like that it is. Clear?
Clear.
Yeah, it's clear.
What are the fields those are involved in bit stuffing? Like startup frame, arbitration field, control field, data field, and CRC sequence. All are encoded by bit stuffing. Then whenever the transmitter deduct 5 consecutive bits of identical value in the bit stream to be transmitted, it inserts a complementary bit in the actual transmitted bit stream. The remaining bit fields of data frames are remote frames. CRC delimiter, acknowledgement field, and end of frame are fixed form and are not stuffed. These fields like CRC delimiter, ACC, acknowledgement field, end of frame, these fields are not stuffed, bit stuffed. They are transmitted as such. The error frames and overload frames are also of fixed form and are not encoded by method of bit stuffing. So the bit stuffing will not be introduced for error frame as well as overload frame as well. Bit stream in the message is encoded using non-return to zero NRZ method, but okay, that is a method used. In the non-return to zero encoding method, a bit is either recessive or dominant. The bit will be either recessive value or a dominant value. This is the diagram which explains how they are doing the bit stuff.